Another type of special right triangle is a 30-60-90 triangle. The 30-60-90 triangle theorem, otherwise known as Theorem 8-6, it states, in a 30-60-90 triangle, the length of the hypotenuse is twice the length of the shorter leg. The length of the longer leg is the square root of 3 times the length of the shorter leg. So consider the diagram, our 30-60-90 triangle. The hypotenuse equals 2 times the length of the shorter leg. And the length of the longer leg is the square root of 3 times the length of the shorter leg. Problem 4, using the length of one side. This one involves algebra. It asks, what is the value of d in simplest radical form? So consider the diagram and the information shown. We have a 30-60-90 triangle. We have a shorter leg length d, that's unknown. We have a hypotenuse length f, also unknown. And we have the longer leg length 5. So what we might think. In a 30-60-90 triangle, the leg opposite the 60-degree angle is the longer leg. So d represents the length of the shorter leg. Write an equation relating the legs. And what we would write? That the longer leg equals the square root of 3 times the shorter leg. And we'd substitute in our values from the diagram. 5 equals d times the square root of 3. What we might think? Divide each side by the square root of 3 to solve for d. And we'd write d equals 5 divided by the square root of 3. What we would think? The value of d is not in simplest radical form because there's a radical in the denominator. So multiply d by a form of 1. So we multiply 5 over the square root of 3 times the square root of 3 over the square root of 3. That's our version of 1. And that equals 5 root 3 over 3. So d, that we were asked to solve for, equals 5 root 3 over 3. Your turn. What is the value of f in simplest radical form? It looks like the same diagram from the previous problem. We're just solving for a new unknown quantity, the hypotenuse.